All right, good day, students. This is a question before us, and it required us to find the equation of the tangent line to the graph of f of x equals to 5x minus 2 over x squared at the point where x equals to 1. So to find the equation of the tangent line, to get the tangent of an equation, what we do is to take the first derivative, meaning that we're going to find f prime of x. That is, we're going to differentiate this function. And the function is 5x minus 2 over x squared. And to write this 5x minus 2 over x squared, we can split that denominator to each term to have 5x over x squared minus 2 over x squared. Alright, so this can be re-expressed as 5 over x minus 2 over x squared. And of course, furthermore, we can write this to be 5x to the power of negative 1 minus 2x to the power of negative 2. So this application is from indices, whereby the denominator raised the power of negative as it is. So having this, now we can now find the derivative of the function. So let's take notes. We have been able to re-express the function as 5x to the power of negative 1 minus 2x to the power of negative 2. Alright, so we can now differentiate this function. So after we differentiate the function, that now give us, to differentiate that, we have minus 5x to the power of negative 2 minus 2 times minus 2x to the power of negative 3. So these will now become minus 5x to the power of negative 2 plus 4x to the power of negative 3. And the question said at the point where x is equal to minus 1. So we substitute 1 into this function. So we have minus 5 into 1 to the power of negative 2 plus 4 into 1 to the power of negative 3. Okay, so finally this one is going to be minus 5 plus 4, which is equal to minus 1. So we have been able to see that the tangent of this function is negative 1. So having the tangent to be negative 1, let's now take note of that the tangent is negative 1. We're still coming to make use of the tangent, which is negative 1. Alright, so now let's come back to the function and let's see what do we have as f of 1. That is, when we substitute 1 into the function, that is 5 into 1 minus 2 over 1 squared. So when we simplify this, we're going to have 5 minus 2 is 3, 3 over 1 is 3. So it tells us that we have 3. So it gets to be that we have a coordinate 1, 3 for the function. So we're going to make use of the coordinate 1, 3 for the function and the tangent negative 1 to find. We're going to make use of the tangent negative 1 and the coordinate 1, 3 to find the equation of the tangent as it is required, a straight line equation. So let's record this. Tangent negative 1 and the coordinate 1 comma 3. Okay, so to find the equation of a straight line, we have the tangent already. So, and to get that, we use this common expression of y minus y1 over x minus x1 is equals to the gradient. So y minus y1 in this case is 1 over, excuse me, is 3. Let me get that corrected. Okay, good. Y minus 3 over x minus 1 is equal to the tangent now. That is minus 1. So when we cross multiply, we have y minus 3 is equal to negative x plus 1. We'll multiply x times minus 1 minus x minus 1 times minus 1, that is plus 1. So we'll rewrite this as y is equal to negative x plus 1 plus 3. When that 3 comes to the other side, it becomes positive. So y is equal to minus x plus 4. So this is the equation of the straight line. That tells us that option B is correct.